Assalamualaikum warahmatullahi wabarakatuh. We continue on our chapter 4, fluid and acid-base balance. Okay, so last recording is about fluid balance, sodium balance. So this one is the third session of this chapter, acid-base balance. So basically acid-base balance is about regulating the free hydrogen ion in the body fluids. Okay, the H plus in our body fluid. Okay, this hydrogen ion and these acids can dissociate in solution to form free hydrogen ion. Okay, acids can dissociate in solution to form free hydrogen ion, and this hydrogen ion can associate with other charges, produce weak acid or strong acid. Okay, strong acid have a greater tendency to do this, meaning to dissociate. Strong acid have a greater tendency to dissociate and form free hydrogen ions, but weak acid has less tendency to dissociate and form hydrogen ions. So it's really harmful if we have strong acid, high amount of strong acid in our body fluids, because this strong acid can dissociate easily and produce a lot of H plus hydrogen ion in the body fluids, and a lot of H plus in our in body fluids will cause acidosis of body systems. Okay, vice versa for weak acid, it has less tendency to dissociate and form free hydrogen. Nevertheless, this H plus from weak acid, if it's too high concentration of weak acid, also can contribute to acidosis of body system. So the second point here, normal pH of blood fluid is around this. Okay, 7.3 to 7.5. Okay, the arterial blood, usually the normal pH is 7.4, the venous blood is 7.35. Okay, so normal pH is around 7.3 to 7.5. Below, rises of above 7.5, so we are experiencing alkalosis or alkalemia. Okay, or drops below than 7.25, we are experiencing physiological acidosis. Okay, Alright, next slide. Concentration of hydrogen ions is regulated sequentially by these three. Okay, I think this is clear enough, but I think I want you to take note that hydrogen ion is regulated sequentially by this one chemical buffer, 2 respiratory center, 3 renal mechanism. Meaning sequentially, meaning if hydrogen ion is fluctuate, the first line defense or the first system that react with the hydrogen ion fluctuation is the chemical buffer. So it act within seconds. If the H plus fluctuation is severe, then after chemical buffer react, the second line defense, the respiratory center will take over to minimize the effect of fluctuation, hydrogen ion fluctuation. Okay, if it's too severe, very chronic hydrogen ion fluctuation, okay, whether it's too excessive or too low, okay, the third line defense will be the renal mechanism. Okay, too severe, our kidney will also help in balance back the hydrogen ions in our body fluid. So this one require hours to days to give pH changes effect. Okay, so sequentially meaning this one. If hydrogen ion too excessive, chemical buffer react first, and it is severe than respiratory, it react after chemical buffer, And then if it's it's very severe, then our kidney will also do their job to balance back the hydrogen ion concentration. Okay, first we look into chemical buffer system. We have three major chemical buffer: bicarbonate buffer system, phosphate buffer system, and protein buffer system. Okay, so let's look into the first one, bicarbonate buffer system. Okay, a mixture of carbonic acid and its salt. The salt is sodium bicarbonate. Okay, potassium or magnesium bicarbonate also works well, meaning this bicarbonate here, the salt, the dissociation, okay, the bicarbonate ion can form or can associate with sodium or potassium or magnesium. Okay, so yeah, carbonic acid and its salt. The salt is whether sodium bicarbonate or potassium bicarbonate or magnesium bicarbonate. Okay, here, if strong acid is added, hydrogen ions release, combine with the bicarbonate ion and form carbonic acid. So it will associate and then dissociate and then associate back with the weak acid, carbonic acid, so forming the weak acid. Okay, in that way the pH of the solution will decreases only slightly. Okay, okay, let's say we have excessive hydrochloric acid in the body. Okay, this is strong acid. This strong acid will dissociate, so it will release it will make free of hydrogen ion, release hydrogen ion. So this hydrogen ion will tend to bind with the bicarbonate ion, okay, forming the carbonic acid. Okay, the sodium over here bind with the chloride, so producing the salt. In this way, it will minimize or decrease the pH fluctuation. Okay, if it's HCl, the pH is too acidic. Let's say we put it 3. Okay, when dissociate, free the hydrogen ion and bind with the bicarbonate ion, produce or build out the weak acid over here, carbonic acid. The pH will not be dropped to 3, but it will maybe by 6. So the pH is slightly decrease. Okay, that's how bicarbonate buffer system helps in regulating hydrogen ion concentration in the body fluid. Okay, just now strong acid, now we go to strong bases. So let's say strong bases is added or added to the body fluid. Okay, this strong base, it will react with the carbonic acid. Okay, carbonic acid H2CO3. Okay, 3. So carbonic acid, the strong base react with the carbonic acid, form sodium bicarbonate. It will form the sodium bicarbonate. This one, sodium bicarbonate. This is weak base. This is strong base. So strong base are high in our body fluid system. So it will dissociate, and then the positively charged of sodium will tend to bind with the bicarbonate ion, okay, build up or making the weak base, sodium bicarbonate. This carbonic acid dissociate, right? So the H plus will tend to bind with the OH, so producing the water. So in this way, in this bicarbonate buffer system, the strong base eventually transform or become the weak base, and this way it will give alkalinity or basic condition of the body, not too basic, it become weak base. Okay, 7 is neutral, basic, let's say 8. Okay, from big tendency to become 8 is less, it will achieving towards 7. Okay, yeah, weak base, right? Please take note that bicarbonate buffer system is actually only the major important extracellular fluid buffer. Okay, meaning in extracellular fluid compartment, the major buffer is bicarbonate buffer. Okay, so let's look into the second buffer system. Our second buffer system is phosphate buffer system. Okay, phosphate buffer system, effective buffer in urine, so and also ICF, intracellular fluid. So major buffer system in intracellular fluid is the phosphate buffer, and also major buffer system in urine is in kidney tubule in urine is phosphate buffer system also. Okay, so how this phosphate buffer system works, it's identical to bicarbonate system. Okay, it will dissociate the strong acid or strong bases, dissociate the strong acid or strong bases, transform that strong acidic acid and strong bases into weak acid and weak base, plus produce salts. Okay, so what are the components? The component is sodium salts of dihydrogen phosphate. So this formula over here. Okay, dihydrogen phosphate is the salt. This salt is a weak acid. Okay, so another component is monohydrogen phosphate. Monohydrogen phosphate is this formula here. Is this monohydrogen phosphate is actually a weak basis. Okay, so in this box here, when strong acid present highly in the body fluid, hydrochloric acid here, the representative, so this strong acid will dissociate, release the hydrogen ion, and that hydrogen ion will tend to bind with the monohydrogen phosphate. Okay, H plus dissociate, right? Chloride. This H plus bind with the monohydrogen phosphate. Okay, the chloride will bind to sodium. Okay, and when free hydrogen ion bind is associate with the monohydrogen phosphate here, it will produce dihydrogen phosphate. This is weak acid. So from strong acid become weak acid. Okay, vice versa for the strong base. Let's see here. Okay, when the body have a strong base, okay, in intracellular fluid, let's mix blue. Intracellular fluid, ICF, okay, strong bases introduced, or high concentration of strong bases in intracellular fluid. So what happen is it will dissociate, and then the sodium, the positive ion, will bind to will tend to bind to this equation over here, okay, sodium the hydrogen phosphate will dissociate and release one H plus, one hydrogen ion. So that hydrogen ion, one H plus here, will associate with the OH, and then produce water. Okay, the sodium will associate with this mono hydrogen phosphate plus 2 sodium, okay, producing this salt over here. Okay, so that's how from strong bases dissociate and produce weak bases, okay, and balance back the pH balance in our body. Okay, lastly, the third buffer system, protein buffer system. Okay, protein buffer system. Inside the cell, we have many types of protein, or inside the cell we have protein, so that proteins can act as protein buffer. From strong acid produce weak acid, okay, or in the blood, plasma, okay, plasma also can act as a buffer, okay, to dissociate the strong acid or strong bases, turn it to weak acid or weak bases. Okay, here example of amino acids of proteins. Okay, some amino acids of protein have these organic acids groups, COH, okay, carboxyl group. So this carboxyl group can dissociate, whether release hydrogen ion or accepting negatively charged ion from weak bases, okay, from strong bases. Okay, so groups that act as weak bases, okay, groups that act as weak bases is this part over here, the amino group in the amino acid. Okay, if you remember the amino acid, each amino acid will have R group, nitrogen group, okay, amino group. The 4 amino acid group. Refresh back the basic structure of amino acid. We have alpha carbon bind with alpha hydrogen, and we have the amino group. Okay, amino group is this one, NH. Okay, and then the the alpha carbon also bind with the R group, the side change. Okay, this one can be variable. and the amino acid have carboxyl group attached to the alpha carbon. Okay, so this carboxyl group can act, it's a weak acid. Okay, and the R group here act as weak bases. Oh, sorry, and the amino here act as weak bases. Okay, so how protein buffer system works? Similar to bicarbonate buffer system and phosphate buffer system, the strong acid and the strong bases present in the body fluid, these strong acid and bases will dissociate and release the hydrogen ion or the negatively charged component. It will associate with these groups over here. Okay, whether carboxyl group or the amino group in the amino acid structure. Okay, so from strong acid become weak acid, or strong bases become weak bases. So that's how from two acidic, that's how the pH will balance in the balance up with this buffer system. Okay,